Welcome to lesson 23, module 6, lessons 23 and 24. We shall see. This could be a long lesson. I was trying to combine these two, lesson 23 and 24, because they both deal with surface area. And I have some idea that if I combine lessons, all of this will go so much faster, but I'm not sure that will be the case. Anywho, let's stop my blabbing and we'll get going. And again, yes, we are talking about surface area. Okay, here we go. Opening exercise here. It says calculate the surface area of the square pyramid. Okay, square pyramid. Again, these are things that we did way back when in module 3. Okay, and those lessons 21 and 22. We did a bunch of these, and we've talked about pyramids recently, and rectangular pyramids, actually right rectangular pyramids. This is a square pyramid, which is still a right rectangular pyramid. Anywho, go ahead and give that a whirl. Come on back, and we'll solve it together, okay? All right, and we're back. And here we go. So, a couple of things I did first is I know that there are 4 faces, okay? And in this case, since it is a square pyramid, I know that all of those faces are going to be equal, okay? Going to be equal. So therefore, I will go ahead and I know I have one single solitary base, which is a square, okay? So, yeah, one base. Therefore, I have 5 different calculations, but not necessarily. I can actually do a little bit of a shortcut, and similar to what we did in the prior lesson. Okay, so the area of the base, really quickly, just to get that done. Again, we're talking about surface area. All right, I have to do the base, and that is going to be 8 times 8, and that is 64 square centimeters. So I have that taken care of. Okay. Now the area of a face, one of these faces, as you know, is 1/2 base times height. And we have the base and the height right there, 8 centimeters by 5 centimeters. All right. Now, because each one of those, of course, each one of those faces is a triangle. Okay. But since we have 4 of those, we can just do this. Area of all faces is 4 times 1/2 base times height. Okay, we can very simply do that. And if we did that, we have 4, and I'm just plugging in numbers here for base and height. And I have 4 times 20, because that's 1/2 times 8 times 5 is 20. And that times 4 equals 80. So 80 square centimeters is my surface area of all of the faces. Okay, so one thing left to do is to add those 2 up, add the area of my base, which is 64 square centimeters, to the area of all of my lateral faces, which are 80 square centimeters, and come up with my final answer here of 144 square centimeters as my surface area for that pyramid. Okay? Again, I'm just going to move along here. Not a lot to talk about. Pretty basic stuff we've been doing, things we've been doing over and over again. It's actually a nice little refresher on what we've done prior and kind of firming up these skills. So here we go. Example 1 says to calculate the surface area of the rectangular prism. Okay, so this rectangular prism here, go ahead and calculate that surface area and come on back. Okay, let's go ahead and do this. All right. Now what I know is that I have 2 of these sides here. We have the base and then we have the top, or the top and the bottom. Okay, we have 2 of those. Okay, and those are both 12 by 6 inches. Okay, so I'm going to multiply 2 times 12 times 6 which equals 144 square inches. Okay, so I have those two. I have that top and the bottom. Okay, and then the bottom under there. Those have been taken care of. Okay. Next, I have the two sides. Okay, these two lateral sides. Okay, we'll call them the sides. So these lateral sides, there are two of those. Therefore, I can write that down as 2 times 12 times 3, okay, which is 12 by 3. That is those are the dimensions of those two sides, and that gives me 72 square inches for those. And then finally, I have those two faces. I guess I'll call them a front and a back, okay, or front and a back in this case, right? Two of those, and again, write that like that, 2 times 6 times 3, and that equals 36 square inches. If I add all those up, I end up with 252 square inches of surface area on this rectangular prism, okay? All right, hopefully you got that. Let's go ahead and take a little bite out of this rectangular prism. You can see letter B, that's what it's asking us to do. Take a bit of a bite there. And so I want you to go ahead and imagine that a piece of the rectangular prism is removed. Okay. Now determine the surface area of both pieces. Okay, so you're going to get the surface area of this piece here, okay, and this piece here as well. Okay, that's where we're going to start. Let's start with the surface area of both of those pieces. I don't care how you do it, how you come to do it. I have a particular way that I'm interested in tackling this one, for instance. Okay, so I want you to go ahead and again, the word of this, the word of the lesson is the word of the lesson from last time is struggle. Struggle with it a little bit. And come on back and we'll check it out. And again, we're just looking for the surface area of both of those pieces at this point. Okay, well, let's go ahead and look and see what I did. Now, here's how I approached this one. I wanted to know, I'm approaching this one here, this C piece. So I want to know what was gained, what surface area was gained from this piece removal, okay? All right? So as you can see, by taking this part out here, this piece out and just pulling it out that way, this piece right here, taking it out, I still have this same face here, this same wall is right here, is being accounted for right there, okay? So they're the same. So that's what we call a wash. They kind of cancel out each other, okay? So there's no change there with that part, okay? All right. But now I do have something that is actually new, okay? This little bit, this face right here inside there, and also this one inside here, okay, these here, these are new. This is new surface area, okay? It's new surface area. I did not have that surface area before because it was, of course, not included because it was a solid piece right there. So those two bits are new, okay? All right. And those two new pieces account for 18 square inches because they are both 3 by 3. Okay, 3 by 3 right there. Okay, and I have two of them. And so that's 3 by 3. Of course, 3 times 3 is 9, times 2 is 18. So I have 18 square inches of new surface area. Okay, new surface area there. But now, what was, quote unquote, lost in the exchange? Okay, what surface area did I lose? Okay, what surface area did I lose? Let's take a look at that. Okay, and if you notice, I have that top and the bottom of this this smaller piece right here that's been taken off. You'll notice they were once part of my larger complete rectangular prism, but they have been actually taken away. So I lost those. I've actually lost that surface area. Okay? And therefore, that is 2 times 6.3, or 6.3, times 6 times 3 equals 36 square inches. Okay, so this part here and then that part underneath as well have both been lost. Okay, they've been lost when this piece was taken out. Okay, so therefore I have gained 18 square inches by these little inner pieces here, these inner faces here, but I've lost 36 square inches because of these. I pulled out this piece right here and lost those. Okay, so now I have a plus 18 square inches and a minus 36 square inches. So finally, my original surface area was 252 square inches plus 18 minus 36. So my new surface area of this one here, okay, looks like a letter C on its side, is 234 square inches. Okay, that one is 234 square inches. Okay, so let's get rid of all that. Okay, clean up a little bit here. All right, and now let's go ahead and take a look at that. So we just put that there. That's 234 square inches. And the small one here, I can't just go ahead and willy-nilly say, well, the other one was 252, so I'll subtract away 234 and I'll get that. It doesn't work that way because you noticed, again, now we have added and subtracted. We actually never had a surface area for this one. So let's go ahead and figure it out. Okay, so our surface area for this one is, of course, 2 times 3 times 3, which will account for the front and the back. Okay, this bit here and this bit here, of course, and then the one that's in the back there. All right, then plus actually 4 times 6 times 3, which is nice because I have 4 of these pieces right here that I've right here, this one and then this one and then underneath and then on the other side. Okay, all of those are actually equal. They're all equal. They're all 6 by 3. So I can multiply those all by 4. Makes my expression here, or my equation, much more concise. All right. So this is 18. This altogether is 72, and therefore I have this new piece right here is 90 square inches. Okay, 90 square inches. So those are the surface area of those two new pieces. Okay. So C over here asks, how is the surface area in part A related to the surface area in part B? Okay, and remember, part A, we had 252. Okay, we had that 252 square inches was our original A. And our new total is 324 square inches. So by removing that piece, we've actually gained a net 72 square inches of surface area. And what's really interesting, I mean, when you study things such as sponges, for example, and in science, if you have a sponge, okay, and a sponge has a series of holes in it, right? Now, what's interesting, so if this one here, if we actually were to push this one forward, this 90 square inch piece here, okay, this one, and push it forward, just connect it right over here somewhere, right at this part, but leave that hole in there, okay, we would actually still have a net gain in surface area. So every little hole in a sponge, okay, adds to a sponge's surface area. Even though you lose a little bit on the top and on the bottom where you've taken a bit out, you are gaining all of that, those inner walls, okay? And this is why a sponge is so good at soaking up water, because there's much more surface area for the water to cling to be absorbed into, okay? That's just a little aside there, just why this is all, to me, so interesting, and why you actually have this net gain in surface area by actually chopping a piece piece off. Okay, so here we go. We have more exercises. We want to go ahead. Here's exercise 1 here. Determine the surface area of the right prisms. Now there's a series of these right prisms actually. What do we have? We have 1, 2, 3, 4, 5 of these prisms before we end this first part, which will be encompass lesson 23. So let's go ahead and start with this one. And I didn't mean to draw those right away, but I'd like you to go ahead and do this work. 1, 2, 3, 4, and 5, and come on back, and we'll do them all together. Take your time. Know what to add. Know what to subtract. Okay. All right. And good luck. Okay, so as you saw already, what I did with this first prism here is I went ahead and the area of the triangles. Okay, we have 2 triangles there that I've traced out there with 2 triangles, and the area of those is 2 times 1/2 times 15 times 8, and again, you know, that 1/2, 15 times 8, this is 1/2 base times height. Okay, and I've already figured those out, and the reason I feel very confident in the fact that I can use my height measurement, okay, is because I know that it is a right triangle, and I should probably just move these here. Okay, there is my little right triangle symbol. Okay, very, very important, because therefore I know that this is what I'm going to use for my height measurement, because my right triangle symbol will allow me to do that. Okay, otherwise my height, I know that this is going to be a straight line. These two are straight lines that intersect here. Okay, otherwise, if I don't know it's a straight line, I'm going to have to I'll have to create another straight line within the triangle, and I hope that doesn't confuse you. But anyway, that's why I was able to use that 8 measurement as my height. Okay, and again, the one side I have 15 feet right down here. Okay, and let's go ahead and then calculate that out. Okay, so that equals a total of, boy, I should probably, so 120 square feet. Made a bit of a mess there. Okay, so 120 square feet. That is the value of those 2 triangles. Okay, so 2 triangles are 120 square feet. Okay, have those. Now I want to go ahead and look at the that one flat base right there, and we can see that's not a base actually. It looks like it would be a base, but it's actually the front, the front in this case, and we can see our dimensions on that front. We have 20 times 15. Okay, so the area of the front rectangle equals 15 times 20, which is 300 square feet. Okay, moving right along. Next, we want to have that other piece right there. That is another face, just with a different dimension. As you can see, we have 17 feet over here. Okay, versus the other different measurement. Okay. So we have that 17 right there, and that's let's call it the back rectangle. 17 times 20, and that equals 340 square feet. Okay, and now we have another piece right there, and that's that kind of area that can be seen from the right. Let's call it the right rectangle. It's the right rectangle. The area of the right rectangle is 8 times 20, which is 160 square feet. Okay, and all we have to do now is add all of that up, and we get 920 square feet. Okay, and I hope you got that. Hope you understand that, and that is smooth as silk for you. Okay, let's go ahead and look at number 2 now, and that is what is that? A trapezoidal pyramid. Okay, it's a trapezoid there in front. Let's go ahead and do the same, kind of take it apart. Okay, look at it side by side. Firstly, at that top rectangle right there, and we know that is 4 times 15. Okay, again, length times width, 4 times 15, so we have 60 square yards for that bit. Look at these. We have 2 of those are going to be exactly the same, those two side panels right there. And those are 2 times 5 times 15, and that's 150 square yards total for those 2. All right. And let's take a look at that base now. We have our base, or our bottom, 10 by 15, okay, and that is 150 square yards, okay. And then we have the trapezoids, okay. And the trapezoids, if you didn't remember the way you figure it out, again, it's 1/2, and then what you do is you add the base and then the top base as well, the top measurement. You add those 2, okay. So let's take a look at what that looks like here. It's going to be 2, 1/2 times 4 plus 10. Okay, so you're going to add those. You're going to add the 4 and the 10. Okay, so you're taking 1/2 of that. Okay, and that's going to be times 4, which is the height right here. Okay, so it's 1/2, kind of 2 bases times height. Okay, it's very similar in the sense to a triangle where you have 1/2 and then you have base times height, but it's 1/2 both bases times height. Okay. All right. Hopefully that's clear as mud, or clearer than mud. All right. And then if we go ahead and do that, we get 2 times 7 times 4. Okay, because we added those up, and then we get because that's 7 times 4. That is 1/2 of 14 right here. If you see that right here, here's our 1/2 of 14. Because 1/2 times 10 plus 4, okay, is 7 right here. Okay, so make sure you know where these are coming from. This right here gave us this. Okay, all right. So 2 times 7 times 4, or 2 times 28 right here is 56 square yards. Okay, and now all we have to do is add all of these up, and we get 416 square yards as our total. Okay, and hopefully you got that. If you didn't, I'm looking here on this. Yeah, there we go. 416 square yards. All right. And again, go back, take a look at it again, and don't worry. Don't hesitate to ever hesitate to give me a call. Okay, so let's look at number 3 here. I'd say it's time to decompose. Take this in different parts. Pretty much what we've been doing. Not necessarily. It's probably not decomposing necessarily, but I wrote that anyway. It's kind of what we're doing constantly here. So first what I did is I went ahead, well, I guess it is time to decompose. I just took that the top section here and the bottom, because they're both the same, and decomposed here. I made them into 2 different rectangles, okay? And again, in the end of it all, if you come up to the same final answer, no matter which way you got it, that is quite all right, okay? Because there may be several different ways to do this, additively or subtractively, whichever. But I took the top and the bottom, I made them into 2 separate rectangles, okay? So the area of the top and bottom, for me, equal 2 times 8 times 6 plus 7 times 2, okay? So these are my two different, let me get my highlighter here. These are my two different rectangles here. Okay, I had 8 by 6 rectangles and then 7 by 2 rectangles. Okay, so you see 8 by 6 and then 7 by 2. So what I did is I had, of course, two sets of those, and that's what that is there. So that total is 124 square feet for the top and the bottom. Okay, and now I went ahead and looked at the that side right there, that left side, and the area of the left side. Okay, and I can come up with my 8 feet there by adding these two here, two that I know, the 2 and the 6. Okay, that's how I got my 8, and that's 8 times 3 because I know the height there is 3, and now I have 24 square feet for that side. And now the back side, I go ahead and figure that one out. That is 8 by 3 because I'm given my 8 there, and I have my 3, and that's another 24 square feet. That front face right there is 7 by 3, and those are two numbers that I am given as well. And then I have that one little piece right over there is a 2 by 3 piece. Again, I can make sense out of that based on what I know. That's 6 square feet, and that other small piece is a 1 by 3, and that is 3 centimeters squared. I almost forgot this one when I was solving this, but as you can see, I've circled all of those, but I did indeed forget about that face I'm about to talk about, that right face there, that blue one, and the area of that right side was 3 by 6. Okay, 3 times 6, and again, those numbers are given to me, and that's 18 square centimeters. And now, if I add all of those together that I've circled in red, those are all my different surface area measurements. I get my total surface area as 220 square centimeters. Okay? All right, let's go ahead and erase all of that. And now work on number 4 here. 4, we have a prism on top of another prism. Okay, so the best way I thought to start solving this is by solving this top prism first. Okay, and the surface area of that prism. The top of the prism is a 4 by 5, so I have 20 square meters. Now I have the front and the back. Okay, they are both the same, so now I need 2 times 4 times 5. Okay, and that's 40 square meters. Okay, and then I have the right side and left side, and that is 2 times 5, which is 50 square meters. Okay, so now I have the exposed part, the surface area of that top prism, because I don't account for this part down here, the part that is touching the bottom prism, simply because it is not exposed. Therefore, it does not offer any surface area. Okay, so now I can work on that bottom prism, and with the bottom prism, now I have that top right there. You'll notice that top in total, I can figure out my dimensions here. They're not given to me, but I can see that they are indeed 10 by 10 because I have 6 meters here in that part, and then 4 meters on this part. So all the way across is going to be 10. The same I can see on this side. I have 5 meters here, 5 meters here, and so that's going to be 10. So it's actually a 10 by 10. But with this top face, okay, I have to now subtract away what is underneath this this top prism. Okay, under the top prism, okay, I need to subtract that away, and I can see the dimensions of that top prism. That's a 4 by 5. So I have to go ahead and subtract 20. So 10 times 10 is 100. And then I subtract away 20. So I'm left with 80 square meters on the top. The bottom is simple because it's the 10 by 10. There's nothing missing because nothing is on top of it. Okay. I have my two sides, two 10 by 3 pieces. And then I have the front and back. And they are two 10 by 3s as well. Okay, and now I have all the measurements I need, all the exposed surface area of this figure, and if I just add them all up, I come up with 420 square meters. Okay, and again, always attending to what is being covered up. Okay, very important. Okay, finally we have this interesting figure. It's like a three-dimensional T on its side. Okay, the area of the top and bottom, okay, faces. I did what I did with that first, with that number 3. I decomposed those top and bottom into 2 different rectangles. Okay, I have a 2 by 10 rectangle. Okay, right there, and that's top and bottom. So I have 2 times 2 times 10, and then I have 2 times 6, which is that rectangle up top, and then of course it's partner 1 on the bottom. Okay, and if I do that, add that up, that's 40 plus 24, so that's 64 square inches are accounted for the top and the bottom of this figure. And now the area of the lateral faces, okay, this is going to be very interesting, but watch here, okay? So if I have now this face right here, I have those 2 bits, those 2 rectangles that I have outlined, and that rectangle. What's very interesting here is that these, all 3 of these, this one here, here, and here, all together are the same area as that back. Okay, so being able to see kind of 2-dimensionally in 3-dimensional space, very, very important here. Okay, so I have 2 of those because I have the back. See, you can see the back right there. I'll finish coloring that in. So I have 2 10 by 9s. Okay, so in the back is a very pure, simple 10 by 9, but up front that 10 by 9 is created because I have 9 here, and then I have 10 all the way across, which is going to include this length, and that length, okay, which makes a total length there. So then I'm going to add 2 times 6 by 9. That's those 2 lateral faces there, okay, in orange. And then I have 2 times 9, which are those the purple face right there, and then the one to the right, okay? And so I have 180 plus 108 plus 36, which equals 324 square inches. So all the lateral faces there highlighted in orange, purple, green, and the ones that you can't see, of course, the accompanying or the partner face that you can't see, those all equal up to 324 square inches. And of course, I just go ahead and add those, and I end up with a total surface area of this 3-dimensional T on its side of 388 square inches. Okay, so here we go. We have our lesson summary, and we're looking at, 33 minutes here. So I think I'll make this actually just a lesson. We'll call this lesson 23, and I will save this one and post lesson 24 separately. Okay? But anyway, what we did here, we have to determine the surface area of right prisms that are composite figures or missing sections. Determine the area of each lateral face and the 2 base faces, and then add the areas of all the faces together. And that's pretty much what we did here, having to account for covered parts as well, in like we did in number 4. Okay, so yeah, being very, very careful. This is not a very difficult activity, but you do need to be very, very careful, and you need to problem solve every now and then with given information to reveal information that you do need that isn't necessarily given right up front. Okay, so anyway, yeah, have fun with your problem sets, and see you next lesson 24. I'll actually do that one separately.